Alright, today we're going to start our first lesson on simplifying radicals. And here we're going to talk about first parts of a radical. You're used to seeing this radical symbol, which is the square root. What we're used to seeing as a square root is what you would call the radical symbol. That part is the radical symbol. And you need to know that there is more than square roots. You can take a cube root, you can take a fourth root. And what that means is a cube root would be something like 2 cubed, okay? If you had 2 cubed, where 2 times 2 times 2, for example, is what that would mean. 2 times 2 times 2, okay? 2 times 2 times 2 is going to equal 8. And so that would be 2 cubed. So then the cube root of 8 would be that number when multiplied by itself 3 times would give you 8, so that would be 2. We know square root of 4 is equal to 2, okay? And I'm going to write over here something too. That would also mean that the cube root of 2 cubed is 2. So if you notice as we go along, when this number and this number match, then the answer here is your answer. So, again, the square root of 4, that it's understood that there's a 2 here as an index when you have the square root of 4. You don't write that. But that's also then the square root of 2 squared. So the number index and the exponent here would match, and so this is your answer. The fourth root of 16. Well, if you think about it, 16, if you want to do a prime factorization, if you're not sure, a prime factorization looks like this when I do them. I kind of do an upside down division mark, where you divide 16 by 2, and that's 8. Divide 8 by 2, and it's 4. And 4 is 2 times 2. So these numbers give you the prime factorization of 16, which is 2 times 2 times 2 times 2. So that means that 16 is 2 to the 4th. Okay? So if I want the fourth root of 2 to the 4th, again, the index and the power under the radical match, that is 2. And those are some things that you need to be aware of as we go forward and do these. Another example, if I have the cube root maybe of 27. Well, 27 is 3 cubed. And if I want the cube root of that, then that answer is 3. Suppose I want the fourth root of 81. Well, if you're not sure of the prime factorization of 81, then go through. We know it's not even, so it won't divide by 2, but it does divide by 3, and that gives us 27, which divides by 3, which gives us 9, and 9 is 3 times 3. So 81 is the same as 3 to the 4th power, and when I want the fourth root of that, you can see again when your index matches your power, your answer is the base number there. So hopefully that's going to help you as we go forward and do some of these problems. Now let's start. We're going to simplify under each radical expression. And we're going to start with the square root of 48. I know it's a square root because there's nothing written in this spot right here. Nothing written, it's understood that that's a 2, so it means the square root. What number multiplied by itself will give us 48? Well, there's no number that we can take the nice even square root of that gives us 48. But what we can do is simplify under the radical. So we're going to do a prime factorization on 48, and we're going to find out that when we divide by 2, we get 24. Okay, and we're going to divide by 2 and get 12. Divide by 2 and get 6. Divide by 2 and get 3. So 2 times 2 times 2 times 2 is 16. So 48 is the same as 16 times 3. Well, 16 is the same as 4 times 4. So the square root, these numbers multiply themselves gives us 16, so the square root of 16 is 4. And what's left that we couldn't take the square root of is right here. The square root is 3, so that can't come out from under the radical. That becomes just, we leave it as the square root of 3. So our answer is 4 times the square root of 3. On number 2 here, we want the fifth root of 64. Well, let's look. 64, if we do a prime factorization, divide it by 2, we get 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. And 2 times 2. 2 to the 1, 2, 1. We have 1, 2, 3, 4, 5, 6 2's. 2 to the 6th power is 64. So we'll write that here. We want the, I'm going to write it underneath so I don't interfere with writing on the side. The fifth root of 2 to the 6th power. Now, if you look over back what we did before, if the index and the power match, then the answer here would be 2. But the index and the power don't match. We have a 5 and a 6. Can we make them match? That's the next question. So yes, the answer is make them match. So we have a 5, and that 2 to the 6th is the same as 2 to the 5th times 2. Well then, we know that the answer to this, when I want to take the fifth root of 2 to the 5th, that has an answer. That answer is 2. That comes out from under the radical. We have found the fifth root of 2 to the 5th. 2 to the 5th happens to be 32. But we have this extra 2 right here that we couldn't take the fifth root of. So that we have to write as the fifth root of 2. We couldn't get that in a group of 5, so to speak. And so our final answer is 2 times the fifth root of 2. Okay, now we're going to come over to number 3, and we're doing a square root again. Again, no number here. It's understood that that's a square root. So think of something, multiples of 18. Well, 18, this one's fairly simple. 18 is 9 times 2. And then we're going to have m squared times m. Remember, we want these powers, what we can, to match the index here that's understood in this case to be 2. Well, 9 is 3 times 3, or 3 squared. So what comes out from under the radical that we can take the square root of, we can take the square root of 9, and that is 3. We can take the square root of m squared, which is m. And that leaves us, what we took care of these, we took the square root of those, they're now gone from under the radical. What has to stay under the radical is 2m, because we could not take the square root of those. Okay. Now we're on the fourth root of 32x to the 6th. Well, if you remember, looking up at our, when we factored 64 up in the problem right above this, we found out that 64 was 2 to the 6th, and so 32 is 2 to the 5th, and then x to the 6th is x to the 5th times x. Whoops, I don't want to do that. I'm back on fifth roots. Let's go back. Alright, so let's write this like this. 32 factored, we'll go ahead and write that, is 2 to the 5th, and we have x to the 6th. But I don't want 5 and 6. I want some that are grouped as 4, because I have a fourth root that I'm taking. So let's figure out how to rewrite these. That's the fourth root of 2 to the 5th is the same as 2 to the 4th times 2. And x to the 6th is x to the 4th times x squared. All right. So now what comes out in front? What can we take the fourth root of? Anything here that is grouped with an exponent of 4 can come out in front, and now we have successfully taken the fourth root. The fourth root of 2 to the 4th is 2. The fourth root of x to the 4th is x. Then what we can't take a fourth root of, what we have to leave underneath the radical, is anything here that we haven't marked out. It's 2 and then times x squared. And so I've taken the fourth root of those numbers. Now we're going to look at problem number 5, where we're taking a cube root, this time of negative 64. Alright, negative 64 is 8 times 8. So let's just think of over here. Let's do a factor tree. Let's just do positive 64 for now. We know that's 8 times 8. And every 8 is 4 times 2. And this 8, I'm going to group it together, is 2 times 4. If I multiply these 2's together, I get another 4. So 64 must be the same as 4 cubed. And it is. But I need negative 64. Well, since our index is odd, I can have a negative number. Remember, we can't do that without having an imaginary solution if it's a square root or a fourth root. If this number in the index is even, then you won't have a negative under here and be able to simplify very well. You'll have an I in your answer. But it's okay to have an odd root. So let's go through, and I'm going to write that out. That's negative 4 times negative 4 times negative 4. That's negative 64. A to the 6th, and since I'm kind of running close on room, I'm going to go underneath, is the same as a cubed times a cubed. And remember, we're taking a cube root. B to the 7th is the same as b cubed times b cubed times b. Remember, these add to give us, when we multiply, they would add to give us the exponents that we see here and here. This, what we've written here, is the same as negative 4 cubed. So let's take the cube root. What's going to come in front of that radical symbol that we will have been able to take the cube root of is negative 4. And we have a times the cube. Let me write it all out. Maybe that's easier. Let's do that. The fourth root of this is a. The fourth root of this is a. I keep saying the fourth root. The third root. The third root of this b is b. And the third root of this is b. And we're left underneath. The only thing we couldn't take the third root of is that b right there. But we need to make this look simpler. We can simplify. We're going to multiply our a's and our b's, so our final answer is going to be negative 4 a squared b squared times the cube root of b. Okay? And over to number 6. Lots of examples today. Fifth root of negative 32. Well, we already know that 32 to the 5th is 32. So we want to group everything in groups of 5. So we have the fifth root of negative 2 to the 5th power. That's going to give us negative 32. And we have x to the 5th. That's already in a group. And y to the 10th is the same as y to the 5th times y to the 5th. Okay. Now, when that comes out in front, what can we take? What can we take the 5th root of? Take the 5th root of this, and it's negative 2. Take the 5th root of this x to the 5th, which is x. Take the 5th root of this y to the 5th, which is y. And the 5th root of that next other y to the 5th, which is another y. Simplified, there's nothing left that we couldn't take the 5th root of. So simplified, that answer is negative 2x y squared. Okay. Now the 4th root of 256. Well, if you know your squares, like I told you, you needed to learn your squares. Let's go over here on the side. I'm going to go to the right side because I have some room. 256 is the same as 16 times 16. And each 16 is the same as 4 times 4. So you can see that 4 multiplied by itself 4 times, 4 to the 4th power, is equal to 256. So this is the same as 4 to the 4th power. There's a negative in front there. So that means my answer for this number 7, and I'm going to erase this just because it's in the way. Okay, my answer is the 4th root of 4 to the 4th is 4, and we have that negative in front that's going to make that negative. So my answer is negative 4. Alright, now let's go to the next page where we're going to talk about performing some order of some operations with radicals. Now you can multiply and divide radicals. There's some rules, always rules. I know that's inconvenient sometimes. You can multiply and divide radicals, okay, if they have the same index. That means this number right here is the same, and then it's just the product. Now this little division problem is off here, but you notice again within that problem the index is always the same. So let's look at our first example, 8. You're going to multiply first your coefficients. So this is the same as 5 times 3, or 15, times the square root of 24 times 8. And we're looking for a square root. So there's a couple ways you can do the prime factorization. You can also say that you have 24 times 8. Well, 24 is the same as 3 times 8. So 8 times, that must mean that this product is the same here. This is the same as 15 times the square root of 3 times 8 squared. Well, the square root of 8 squared is 8. So that's going to be the same as 15 times 8 times the square root of 3. And that's going to equal, when I multiply the 15 times the 8, 120 times the square root of 3. Okay. Now, this is a division. just like the product, we could multiply them together under the radical. We can make this one single problem, taking the cube root of 48 divided by 2, which is the same as the cube root of 24. Now we've already decided that 24 is 8 times 3, so that's the same as the cube root of 8 times 3. Well, 8 is 2 times 2 times 2. So that means we're taking the cube root of 2 cubed times 3, because 8 is 2 cubed. So the answer here, we know the cube root of that is 2. And what's left that we couldn't take the cube root of is this 3 here. So the answer is 2 times the cube root of 3. Alright, so first on this number 10, let's multiply these together. Let's combine them all as one and then group them in groups of 4. We notice that the A here is already a group of 4 and this one's not. So I guess we really don't have to do that twice. So we've got the fourth root. 8 times 4 is 32. We've got A to the fourth times A squared. And we're going to have B to the 15th. 10 plus 5. Alright, now 32, if we remember, 32 is equal to 2 to the 5th power. So when we rewrite this with our groups of 4, yeah, maybe I better do that under here. That's 2 to the 4th times 2. 2 to the 5th, I'm going to break that up with one group of 4 times 2. We have A to the 4th times A squared. We left that just like it was. B to the 15th, breaking that in groups of 4, that's B to the 4th times B to the 4th times B to the 4th, that's 12, times B cubed, 13, 14, 15. Okay. Now I'm going to go ahead and put my answer right here, underneath, or right here beside the problem. This is going, when I take the fourth root, this is going to come out as a 2. This is going to come out and take the fourth root of that, will be A. I have B times B times B, so that's going to be B cubed. And then what we couldn't take the fourth root of stays under the radical. Be sure to write your index in there. And that's going to be 2B cubed left underneath that radical symbol. Oop, I forgot an A squared. So I have to put here an A squared. I forgot that. We have this one, and this one that stay under the radical. In our last example on multiplication, we're kind of, this is a division problem. We're kind of going the other way with it. Instead of going from 2 radicals, numerator and denominator, into 1, we're going to go from 1 to 2. Because again, if you know your roots, like I've told you probably need to, this 27 is the same as 3 times 3 times 3. So that's the same as the cube root of 3 cubed. And 8 is the same as the cube root of 2 cubed. So I could take cube roots of each of these numerators. So instead of dividing, and I can't get 27 divided by 8, I get some decimal answer. I can't reduce the fraction. But I can still do this problem and get a nice answer because I can take the cube root of each one. And that was that rule that's up at the top of the page. So the cube root of 3 cubed is 3, and the cube root of 2 cubed is 2. Okay. Now let's look at our addition rules. Okay. Our addition rules. You can add radicals when both the index and the radicands are the same. So what that means is this part underneath the radical and the number in the little crook have to both be the same. And in number 12 example, they are. Now what I want you to remember is when we add, and you would all give me the right answer if I said, what is 3x plus 2x? You would all look at me and say, okay, that's 5x. This part didn't change. 3 times x plus 2 times x equals 5 times x. And so I want you to think of this kind of like that x. 2 times the square root of 3 plus 3 times the square root of 3. If those are exactly the same, if behind or x we have a square root of 3, then that means that that number is not going to change in my answer, because the tendency of students is to change that and do something with it, try to add them or multiply them. But we don't. What you add are these coefficients in front. So that becomes 5 times the square root of 3. Okay, basically the same example. Now where we get into a few problems with our addition are here as we're looking at an example like in number 13. The radicands here are not the same, but perhaps they will be when we simplify under the radical. So let's just look at number 2 here, or number 13. We have 2 times the square root, and 50 is the same as 25 times 2, minus 80, and 80 is the same as 16 times 5, plus, I'm running out of room, 3 times the square root of 125, which is the same as 25 times 5. So now let's simplify what we see here. Let's go ahead and take square roots where we can. We have 2, because that times, and the square root of 50, square root of 25 is 5, and we're left with the square root of 2 underneath, minus 80, square root of 16 is 4, and we're left with the square root of 5 underneath the radical, plus 3 times square root of 125, that's going to be 5 times the square root of 5. And I'm going to kind of separate that out so it doesn't look like it's part of the problem. Now we need to go through and multiply where we have coefficients right there that we have to multiply together. So that 2 times 5 is 10 times the square root of 2, minus 4 times the square root of 5, plus 15 times the square root of 5. Now I want you to notice that this and this are the same radicand and index. 2 is not, is it? This one doesn't match. So we can only add the coefficients in front of the indexes and radicands that match. So our final answer, we still have to have 10 times the square root of 2, and then we'll combine negative 4 plus 15 is 11 times the square root of 5. We combine the ones we can, and the ones we can't you have to leave as they are. Alright, let's look at our last two problems. We want the fourth root of 80. Well, 12 times the fourth root of 80, we said 80 was 16 times 5. So 16 is 2 to the fourth times 5, plus 18 times the fourth root of 5. Okay. So here we have 12. The fourth root of 2 to the fourth is 2 times the fourth root of 5 plus 18 times the fourth root of 5. 12 times 2 is 24 plus 18. If I go over here, let me just move this over. Let me rewrite this farther over to the left. This is 12 times 2 to the fourth root of 5 times the fourth root of 5. Erase this. I'm moving it over just to give myself some more room here at the bottom. Plus 18 times the fourth root of 5. That's the same as 24 times the fourth root of 5 plus 18 times the fourth root of 5. And so my final answer I'll write here, 24 and 18 is 42 times the fourth root of 5, which is my final answer for problem number 14. Now problem number 15, you've got cube root, well, let's rewrite that. You've got the cube root of 2 to the fourth plus the cube root of 27 times 2. And 27 is 3 cubed. So let's rewrite. We've got the cube root of 2 cubed times 2 plus the cube root of 3 cubed times 2. The cube root of 2 cubed is 2 times the cube root of 2 plus 3 times the cube root of 2. These came out in front. Remember, we could take the cube root of those, and those numbers come out in front of the radical. And what we couldn't take the cube root of is left underneath. Again, the index and radicand match. Both the number here and the number here are the same. They match each other. They're not identical. The index for the coefficient 2 and the index for the coefficient 3 match, and the radicand for each match. So then we can add the coefficients. We can add the 2 and the 3. And so my final answer here will be 5. 2 plus 3 times the cube root of 2.